Hi, in this video, we're going to be looking at different isotopes of our elements and using the abundance of each one of these isotopes to calculate our atomic weight. We did a little bit of this earlier in the year. We're going to get into a little bit more detail with it, and we're also going to talk about mass spectrophotometry. And so this handout you're going to do along with the other handouts that will be posted on Google Classroom, along with additional videos that I'm going to have you watch. Okay, before we get started, we need to clarify the difference between the mass of an atom and the mass of our element. So whenever we talk about our atomic mass, we're referring to the mass of just one atom. And then we also have what's called our atomic weight. And that's our weight that we see on the periodic table. And that is the weighted average of all of the isotopes. So when we talk about atomic mass, it's the mass of just one atom, and it's going to be a whole number. So for example, if we have chlorine 35, and we have one single atom of chlorine 35, that chlorine has its 17 protons in the nucleus, and it has its 18 neutrons. So the 17 protons, the 18 neutrons, that gives us our mass of 35. So that single atom of chlorine has a mass of 35. When we talk about the mass on the periodic table, that is the mass of all of the isotopes. And to figure that out, you take the percent of abundance of each one of those isotopes times the mass of each one of those isotopes. And we're going to be doing a little bit of those calculations. Now, sometimes when you look at your atomic weight and you look at problems where you find the atomic weight, you'll see something that's referred to as AMU. AMU stands for atomic mass unit. Most of the time we just talk about the mass. And so, for example, if we have this chlorine atom and we say that it has a mass of 35, which it does, that's the protons plus the neutrons, we might also see something that's called the adjusted AMU. So the AMU is an adjusted value. It's not exactly 35. It's 35.969. And the reason that number is slightly different than what we would expect for when we add up the protons and neutrons, that number is slightly different because there is mass lost due to bound energy. So there's a loss of mass due to energy that is bound. And we can use equals mc squared to help us determine that mass. Energy equals mass times the speed of light squared. Right, so if you ever see these numbers that are slightly less than what we would expect, they could also be slightly more, but slightly different than what we would expect, and that's our AMU. It's an adjusted value, so it's slightly different. All right, so when you're given these problems, you might be just given your standard normal number like you would expect. We did some of those earlier in the year. You might be given your AMU, which is an adjusted value, slightly different. You can solve these problems either way. If you're expected to use the AMU, it would obviously have to be provided. Otherwise, you can just use the mass provided for each isotope. Okay, so here's an example of an element with different isotopes. And here we have some made up element, element A, and it has 3 different isotopes. Okay, so we have 3 lines. Each line represents an isotope. And to get these lines, we use what's called a mass spectrophotometer. And this would be what we call a mass spec. It shows us what the percents are of abundance for each one of our isotopes in a given element. So this is element A. It has 3 different isotopes. It has a 60, so we have this isotope right here. So instead of saying, for instance, carbon 12, we're just saying A60. So element A with a mass of 60. This peak right here represents element A with a mass of 61. And this peak right here represents element A with a mass of 62. And when we look at this mass spec, we can see that most of our isotopes are isotope 61, approximately 82.1%. So the magnitude or the height tells you the percent abundance. This isotope is 82.1%. Now, I gave you these values down below, but you could also get them if you had a graph like this to look at. Then we have our isotope 60. It has a percent of 10.6. And then we have our isotope 62, which has a percent of 7.3. Okay, these are the percents abundance. They tell you how abundant the isotopes are. Okay, so this is all the data that we need, and this is also data that was provided in that table. And so what we're going to do is we're going to take our 3 isotopes and we're going to calculate our weight. Like I said, we did this earlier in the year, but instead of using the AMU, we just use these values right here. Probably going to get a really close number. Okay, so what we'll do, we're going to take each AMU. So I'm going to take the AMU for A60. So isotope 60 has an AMU of 59.9556. And that makes up 10.6%. So I'm going to multiply that by 10.6%. 10.6% is the same thing as 0.106. And when I do that, I get 6.3552936. Okay, I'm going to do the same thing with my A61. It has an AMU of 60.94107, and it's 82.1%, so 0.821. And when I multiply that, it gives me 50.0326. And then our third isotope is A62. It has an AMU of 61.928345. And it makes up 7.3%, which is 0.073. And then when I multiply this, I get 4.8304. Okay, at this point in time, I can just add up all of my values. And I'm going to do 6 digits. You could probably go on and on and on with these, but we're going to do just 6. And so this adds up to equal 61.2183. Okay, so we just found the atomic weight of element A. Okay, just like we did earlier in the year. Try number 2 on your own. So pause this, try number 2 on your own. Okay, number 3 is a slightly different type of problem. So in question 3, we're given the mass of the element, and we know the different isotopes of that element. We just don't know the percents. And so what we're going to do is find the percents. Okay, so I'm just going to write down what I have here. I have this right here. Okay, this goes with isotope 80. And I have this AMU right here that goes with isotope 82. And we know our average is 80.537. So my isotope 80, I can make that my X. And then I have my isotope 82. And this is going to give me a total of 1. So I can make my isotope 82 1 minus x. Okay, so if my isotope 80 is my x, then my isotope 82 is going to be 1 minus x. So I can set this up into solve algebraically. And so I'm going to take my 79.94, which is my isotope 80, times x plus my isotope 82, which was 81.83. I'm just replacing these values for my isotope 80 and my isotope 82. And we said isotope 82 is going to be 1 minus x. And when we add these all up, so our AMU, or isotope 80, times the percent of that isotope, we're going to make that percent x. And then our 82, which was 81.83 AMU, times 1 minus x equals 80.537. Okay, so x will equal the percent of our isotope 80. 1 minus x will give us the percent of our isotope 82. Okay, so let's just go ahead and solve. We have 79.94x plus 81.83 times 1 is 81.83. 81.83 times negative x is negative 81.83x. All right, now here we need to get our like terms together. So I'm going to go ahead and subtract out the 81.83 on both sides. And that gives me negative 1.393. Over here. And this makes this go away because I subtracted it out. And then I'm going to combine my x values. So I have 79.94x plus negative 81.83x, which gives me a total of negative 1.99x. Okay, now I need to get x alone. So I'm dividing the negative 1.99 to get rid of this next to x. Divide both sides by negative 1.99. And when I do that, okay, that gives me x equals 0.7. Okay, what does that tell me? If my x equals 0.7, my 1 minus x equals 0.3. So that tells me we said D80, so isotope 80 was x, and we said x is 0.7, so 70% of our mass is made up of isotope 80. And 1 minus x gave us 0.3, and so that means that 30% of our isotope is made up of isotope 82. That's how you find your percent isotope abundance of your isotopes. You could even take these values and plug them back in and make sure when you're done that you get this value just like we did in number 1. So you can use these percents to check your work. Okay, try number 4, and then complete the remaining assignments that are posted for you on Google Classroom.